So we've been spending our time talking about ionic bonds, which, as you know, involve positive ions and negative ions. And opposite charges attract. So you have these really strong bonds. Think about two really strong magnets and how they attract each other, how hard it is to pull them apart. Ionic bonds form crystals that are a repeating pattern of these positive and negative charges. And you've spent a few days working with the names and the formulas for ionic compounds. And today we're going to talk about the counterpart there, covalent bonds. Covalent bonds are formed when two atoms with strong attractions for electrons, atoms that might gain electrons, but instead they begin to share electrons. Notice representations of covalent bonds will often show electrons between the nuclei of two atoms. They often show electron clouds overlapping. Covalent bonds are formed when two nonmetals bond together, a nonmetal and another nonmetal. It is pretty important that you remember where our division between the metals and the nonmetals are. And keep in mind that some of these elements along that stair-step line are what we call the semiconductors or semimetals, because they can exhibit properties of metals and nonmetals. When two nonmetals bond together, they bond in a different way because both atoms are seeking out, pulling towards themselves these electrons that are available between the two of them. So they begin to share. So rather than this magnetic attraction between positive and negative, you want to think about it as more of a tug of war between two people using some sort of an elastic rope. Sometimes that connection will get stretchier and those two people might be further apart, but sometimes they're going to be really tightly put together with that rope in the middle, that elastic rope that they're pulling on. So you get something a little bit different. You get a bond that it tends to be more stretchy, more flexible. And the properties of substances reflect the properties of those representative particles, and by that we mean the crystals, the molecules. So whenever you have a substance and it's made up of nonmetals, you must be able to recognize that that's a covalently bonded compound. The naming for what we call molecular compounds because covalent bonds form molecules, or covalent compounds. It doesn't have any math involved because there's no charges. There's no charges to look up. So when we approach this naming system, it's really a language. It's a linguistic skill. And the first thing that you need to be able to do is count to 10 in chemistry. And this is how we count to 10 in chemistry. Mono means 1, di, 2, tri, 3, 4, tetra, penta, 5, like a pentagon, hexa, like a hexagon, is 6, hepta, 7, octa is 8, nona is 9, and deca is 10. A decade has 10 years. Deca means 10. These prefixes come from the Greek language, and so they're often referred to as the Greek prefixes. There's another chart. So you're familiar with one covalently bonded molecular compound because it's so important in biology: carbon dioxide. Keep in mind, there's no math, there's no switching, there's no charges. We're going to look to see what we have, and we're going to state linguistically, with language, what's there. I see 1 carbon. I could say monocarbon. I see 2 oxygens. That's dioxide. The IDE ending tells the listener or the reader that this is a compound. This is not a list of elements that are not bonded together. Rather, this is elements that are bonded together as a compound. So we could call this monocarbon dioxide. But you're used to hearing this called carbon dioxide. And that's because the rule is if the first element, only the first element, only has one of an element, we're allowed to leave the mono off. You may be familiar with a compound, carbon monoxide. It's a primary ingredient in automobile exhaust. If your engine isn't running properly, you have a lot of carbon monoxide fumes coming from your exhaust. And even if your engine is running properly, you're going to have some. It's a dangerous substance. It's poisonous. Carbon dioxide isn't. When we look at carbon monoxide, we have 1 carbon and 1 oxygen. Carbon monoxide. I'm going to run out of space there. My point is, if you're familiar with carbon monoxide, again, we could say it's monocarbon monoxide, but we're allowed to eliminate the mono only on the first element. On the second element, we can't do that, so we call it carbon monoxide. Again, this is a language skill. We're translating what we see, 1 carbon and 2 oxygens, translate that into a language. Carbon dioxide. We look at what we see, 1 carbon and 1 oxygen, carbon monoxide. So as you can see, we still use the IDE. We use a prefix for the first element if there are more than one of that element. This would be dinitrogen dioxide. But this would be nitrogen dioxide. We always use a prefix for the second element no matter what. We change our ending to IDE just like we always have. So if we see something and we want to name it, we look up the symbol's name. If the subscript is above 2, this one's not, then we'd add a prefix. Note, prefix comes first. For the second element, no matter how many are there, we add a prefix. There's 3, I'm putting tri. We change the ending of the second element to IDE. Sulfur trioxide. Okay, pause. Try these. One phosphorus, 3 hydrogen, phosphorus trihydride. Hydrogen monoiodide. Dinitrogen trioxide. Only the ending changes to IDE. My apologies that my subscripts didn't come up when I went from PowerPoint into this program. If you download the PowerPoint from the website, your subscripts are going to show up properly there. On your worksheet, for your homework, you're going to do the same thing. Write down the name of the first element. It gets a prefix if there's more than one. The second element always gets a prefix no matter what. I think it's worth noting that with a few of these, we adjust things. Monoxide. Oops, sorry about that. If we had monoxide and we didn't drop one of these O's, it would be monoxide, which is a little weird. So when you end up with a couple of vowels that come together and clash in these names, you just drop a vowel. Again, which one do you drop? What do you do? When do you do this? You're going to learn that through experience, through doing your homework, through reading the text, through seeing the examples. You'll get a familiarity with these words, and you won't struggle with that. we write the first symbol, always use a prefix for the second one, always change the ending to IDE. Well, if we get the name and we have to write the formula, it's just a language. Read it and translate it. Try. There's 3 of something. 3 what? Silicon. Tetra. That means 4 of something. 4 of what? Nitride means nitrogen. Done. After doing ionic compounds, this is a breath of fresh air for you. There's no math. There's no positive and negative charges. There's no switching. There's no parentheses with polyatomics here. It's just straightforward. What do you see? Translate into the right language, which is the language of chemistry, and you are done. Try these. And check your work. On the other side of your worksheet, you have a word bank. If you have not read Chapter 5, now's a great time to go back and do it because we've worked with those concepts enough in class that it's just going to enrich your knowledge of the background material. The hard parts, the skills, you're already going to know. Chapter 6 is where you're going to find your covalent bonding information. Definitely read that chapter. Some of it will be a little bit confusing to you at first, but it's going to give you a richer view of all of these things that we're talking about in class. Take the time to read through those chapters. A little bit of help here on this word bank section. Ionic compounds that absorb water. Those are hydrates. If we're talking about ionic compounds, what comes first? Always the positive ion. Binary just means 2 elements. This you will get from your reading. The second element in a molecular or covalently bonded compound is always the one that has the highest electronegativity, which, if you remember from our previous lesson, it means an attraction for the electrons. So when we look at carbon dioxide, they're sharing electrons. There's no cations or anions. Oxygen came last because it has a greater attraction for those electrons than carbon. We'll be talking about how to name acids this week. So make sure you get some practice with these covalent compounds right away so that you feel ready for something new. And that, ladies and gentlemen, is the end.